We were talking about the transport layer being able to provide both reliable and unreliable data communications. So how do we do that? What actually happens? Well, the two protocols that we use at the transport layer, TCP and UDP, transmission control protocol gives me reliable communication, and UDP is unreliable. Again, I don't know if I want to say unreliable, best effort. It's unreliable at layer 4. It's unreliable at the transport layer, but the applications are going to guarantee communication for me. So if we take a look at how the reliable piece works, it would probably make a little bit more sense as far as actually setting up that session. When we want to build that communication scheme, so we're going to be talking from our PC out to our server someplace. Yes, I guess I don't really need a line that big. We'll make it a small line, which will make it easier for you. So my communication from my client out to my web server, I need to build that PDU that we talked about before. So I have my HTTP request as a GET request, and then the next header was that transport header, the layer 4 header. In the case of HTTP, as defined by TCP, and those are my port numbers. So I want to talk to my server on port 80. Well, before we can do that, we have to set up reliable communication between my client and my server. So the first thing that happens is, at the transport layer in this header, we do in fact send a PDU to the web server, but in the TCP header, we actually just set what's called the SYN flag, or the SYN bit. We set that to a 1. And I'll show you that in just a second, that the SYN bit gets set and on the way to the server, which means I want to synchronize communication with you, please. That, as soon as the server hears it, the server knows that my transmit is working and its receive is working because it heard me. It needs to tell me that it heard me, so it sets its ACK flag, which is acknowledgement, leaves the SYN flag in place and sends me a SYN-ACK back. As soon as I get the SYN-ACK from the server, I realize that the server heard me, so I know that my transmit pair and their receive pair is working. I know that their transmit pair is working and my receive pair is working because I just heard them. But you know what the server doesn't know? The server doesn't know that I can hear it. So what I do is I clear the SYN and I just send the acknowledgement back to the server that says, yep, I got you. This is what's called that three-way handshake. And that's what actually sets up the session that's being used. And again, we call this a session. We call this the TCP session or the transport session. Not to be confused with the session layer of the OSI model. This is a TCP session that gets built here. And that actually establishes or allows me to establish that communication. If we would actually take a look at it, I talked about setting the SYN flag or the SYN-ACK flag. What does that actually mean? What does that do for me? Well, if we take a look at Wireshark, Wireshark will give us a breakdown of what that header functionality looks like. In a Wireshark interface, now again, I think we've talked about Wireshark before, but Wireshark is a sniffer. So I'm sniffing packets, and if we look at what Wireshark does, first off, what's interesting here is in Wireshark, if you hadn't noticed this before, there's the Ethernet section, that's the MAC address header. There's the IP section, that's the Internet Protocol header. This is the TCP section, that would be my transport header. And then ultimately down here, below what you can see down there is going to be an HTTP section, and that would be the application header. So that same PDU that we built right here, if I continue and finish the rest of this PDU, this would be my IP header. This would be my MAC address header out here. And again, I can't not do this for the sake of completion. Sorry about the double negative there, FCS. This is this whole PDU structure here. This is what Wireshark is looking at. This PDU structure, this is really just the headers. So if I look at the HTTP header, that's this information from my PDU. When I look at the transport section here, which we've actually clicked on the little plus sign right there, and this whole section is now the transport section, that's the TCP header. That's what that is. Again, if I were to click up here to the Internet Protocol section right in here, and what would happen is that would actually be all the IP header information. In the TCP header, there's a section called flags. Again, I'll circle it for you here so you can see it. That flag section is actually a bitwise representation. So it's a 2-byte field, and what happens in here, every bit means something. So if this bit right here is set, which means I've turned it to a 1, that's a reset bit. If the second bit here is set, that's a push bit. So in our environment, we're trying to do a SYN SYN-ACK ACK, so I would expect the SYN flag to be set, and sure enough, this is the SYN flag right here. This is getting the blue highlighting, and if you fall over, it's a 1. That means this is a SYN segment, I guess is the better term for this, because that's the terminology that we use for for the transport layer. In the top piece here, this is the one that's highlighted. It's a SYN packet. If we were to look at the second one, it would be a SYN-ACK. And if I look at the third one, it's just an ACK. So these three, SYN, SYN-ACK, ACK, is the reliable communication for my TCP session.